Hello and welcome to Pyramids Part 2. As you can see, I have an actual example here with some numbers in it, and I'm going to try to find the total surface area of the pyramid that you see drawn right here. This one's nice because it's a square-based pyramid. It's 20 by 20, and then I've got to figure out these four triangular faces and then add them to the area of the base to get my total surface area, to get my final answer. So let's start off with the really easy part, which is figuring out the area of the base. Well, the base is pretty nice because it's just a square. So it's just going to be 20 times 20, or 400 square centimeters. Where things get a little trickier is when you're doing the lateral part of the pyramid, and that is these four triangles. Well, the good news about it is at least the four triangles are all the same shape. So that means I'm going to cut down my work a little bit by doing the following. If I get the area of one of those triangles and then times that by 4, that's giving me the entire lateral area. So what would be the area of a triangle? Well, it's 1/2 the base times the height. The base and the height of the triangle specifically. Well, it's easy enough to see the base of each triangle. It looks like it's 20 along the bottom for each of the four triangles. So that's not bad. Where it gets tricky is figuring out the height of these triangles. So let me just change my pen here, and I'm going to put in an extra line to show you the height of the triangle. That's finding this line here. Okay, that line is the height of the triangle. And what I'm going to do is I'm going to draw one of these triangles. If I was looking at one of these triangles sort of head on, what it would look like. It would look something like this. Just doing a mini version here. Okay. And this is the height of that triangle. So let's label the height. So I'm going to make the height here x. And that means this is x over here. This height here. And along the bottom, the base is 20. So I just got to figure out what x is. That's the height of the triangle. That's what goes in to my formula over here, and then it's just a simple calculation. So how am I going to get the length x? Well, if I look from the front here, I've got this nice little right triangle, so I'm going to use Pythagoras' theorem. Now this side over here along the triangle is actually half of 20, so this would be 10. So I've got the two sides of the triangle, and I'm trying to find the hypotenuse x. So if I use Pythagoras' theorem, it's going to look like this. I'm going to have x squared, or hypotenuse squared, equals 16 squared plus 10 squared. So I'm going to go ahead, square the two numbers, and then add them up. So x squared would equal 356, which means x is the square root of 356. Now, if I was really wanting to be exact, I would leave this number as the square root of 356. But if you want, you can also change this to a decimal approximation, which is about 18.868. And you'll notice I'm using 3 decimal places. What you don't want to do is any early on rounding. Try to keep at least 2, or better yet, 3 decimal places. Okay, just going to switch my pen over here and figure out what this calculation is. So I'm going to go 4 times 1/2, which is kind of like saying 2 times 20 times 18.868, or square root of 356. When I did that calculation, I found it to be 754 0.72. And remember, to give my final answer, I got to add the base. So I'm going to take this 754.72 and I'm going to add to it 400. So here's my surface area for this pyramid. It's 1154.72, and the units there would be square centimeters. And there's my answer. So a little bit of Pythagoras' theorem and a little bit of addition, but it all worked. So with that, I'm going to stop and I'll see you later.